All right, hopefully you watched that intro and so you got a quick reminder of the differences between linear, quadratic, and exponential. So for number 1, it says that Renetta is creating a design for a craft project. Write an expression to express the number of shaded squares in each piece of the design. So the important stuff, we are writing an expression and the shaded squares. So let's just do a basic count. Design 1 has 2 shaded squares. Design 2 has 3. Design 3 has 4 shaded squares. And Design 4 has 5 shaded squares. So if I were to, now this one's pretty basic. You can probably see what the pattern is so far. But let's go ahead and fill out our XY chart. And I would recommend doing this for all of your problems. So our X values are going to be the design number, and our Y values are going to be the number of shaded squares. So design 1, 2, 3, and 4. And how many shaded squares we have in design 1, we have 2, in design 2 we have 3, we have 4, and in 4 we have 5, and so on and so forth. Right, so when we go to create an expression, we want to see what we have to do to our X value to equal our Y value. Well, here for the first one, to get from 1 to 2, you would just add 1. From 2 to 3, you could add 1. From 3 to 4, you could add 1. So that's more than likely what our expression is going to be. So let's see. Let's also graph this. So I kind of went out of order. I should have graphed first. It's all right. So we have 1, 2, 2, 3, 3, 4, 4, 5. And we can see that all of our dots are in a straight line. And also our common difference, we are adding 1 each time. And we could add that pattern. So that's where that +1 comes from. So let's just make sure that we are right. So we're going to substitute our X value into our expression, and we get 2. Now we substitute 2 in, we add 1, we get 3. Substitute 3 in, add 1, we get 4. Substitute 4 in, we add 1, and we get 5. So this lines up with our chart. This expression gives us the next value. So our answer over here, you can see it's a line. We have a linear problem, and our expression would be X plus 1. All right, let's look at number 2. So number 2, we have 3 candidates, and they tell 3 other people about the election that will be held on next Tuesday, and those 3 people tell 3 more people, and it wants us to write an expression to model the number of people that will hear about the election next Tuesday. So we are going to say our first round of people are the ones running for student body government, and there are 3 of them. Those 3 people tell 3 more people. So the second round, that's how many we have. And then those people tell 3 more people. So this is our third round. So these are going to be our X values, and then the number of people are going to be our Y values. So let's go ahead and fill in our chart over here. So the first round, second round, third round. And in the first round, 3 people know about it. Second round, we have 9 people, and in the third round we have 27 people. All right, so let's take a look. If we go from 3 to 9, we could add 6, or we could multiply by 3. Well, if we add 6 to 9, we get 15, which isn't 27, so that one's out. But if we take 9 times 3, we get 27. And remember which one had a common ratio, and a ratio is something that you multiply by. It was exponential. So this one's going to be an exponential problem. I keep wanting to say function, but we're not quite to the functions yet. So it's an exponential problem. Let's go ahead and graph and see what it looks like. So in our first round, we have 3 people. Second round, we have 9 people. And in the third round, we'd be way off up here in the sky. So you can see it gets really, really big, really, really fast. And let's remind ourselves that exponentials are a to the power of x. So our variable is the exponent. So we start at 3, so that's going to be our a value. So since our a value is 3, our expression should be 3 to the power of x. Now let's try it out by substituting our x values in. So we have 3 to the power of 1, which is 3, 3 to the power of 2, which is 9, and 3 to the power of 3, which would be 27. And so we could continue on this pattern. If we had a fourth round, 3 to the power of 4 would be 81. So by the fourth round of people telling everyone, 81 people would know about it. So word would get around really fast. That's the point of the exponential. So this worked. Those line up with our table. So our expression would be 3 to the power of x. All right, stay tuned for our next few examples.